Hi, I'm Hannah Von Vecchio, and this is my Lab 5 on Freefall. The purpose of this lab is basically everyone got to choose their own lab, but the purpose of my lab for Freefall is to observe an object in Freefall and find final position, initial velocity, final velocity, and total time, and then verify whether the numbers from tracker verify the actual distance the objects fell, so if it matches the same motion. So the results, the object will take a small amount of time to fall because we're only dropping it from a meter. And then the numbers from tracker will have slight inaccuracy from the actual distance, but it should be close. The important physics fundamentals for this lab are, of course, Newton's first and second laws, basically stating that if something's at rest, it's not going to move, and if it's moving, it's going to move in the same velocity unless it's acted on by something else. And then the second one is just delta P equals F net times delta T. And those are important because your x isn't going to change for this one just because we're dropping it straight from one point. So we're working entirely in the y. And free fall basically is just acceleration due to gravity, where you don't have an initial velocity. So your final velocity is just your acceleration times time, and then your distance equals 1/2 at squared using kinematic equations. So the first step is to observe the motion of the object. This is basically what it would look like when we drop it. We're starting at an initial velocity of 0, dropping it, and it's accelerating at 9.8 meters per second. The important materials that we need are, we're using an eraser with a mass of 0.0085 kilograms, and then a calibration stick, and this is just 1 meter stick. And then when conducting this experiment, it's important to be careful when you drop it. Make sure you're literally just dropping it and not adding any velocity to it. And then make sure it falls in a semi-straight line. Next, we analyze the object in tracker. Our system was the eraser. Our surroundings is Earth because it's already included in the kinematic equations, and it's just kind of acting as an outside force here. Ruler, and then the person dropping the ball. Basically, it's just entirely the eraser falling. And then your initial conditions, we said initial velocity 0, distance 1, and then your g is 9.8 meters per second. Our results from basically tracking the point mass in tracker was that we got an initial time of 0, final time of 0.6 seconds, an initial velocity of 0 meters per second. We already knew that. And then our final velocity is negative 3.97 meters per second. Our distance was 0.803 meters uh, according to tracker, but it was actually 1, which isn't a horrible estimate, but it's not exactly the same. And then it falls at a relatively steady rate. You can see the line here of y, basically when we ended up dropping it. And you can see it's pretty straight, and it should be a straight line. So possible sources of error, change in direction, so maybe the object changed direction a small amount in the air, or it didn't fall in a straight line. But the most likely error is error with the location of the calibration stick or tracker, and then error with point mass. So what if the object were initially thrown straight up with the same initial speed? We had an initial speed of 0, but we'll assume that it's we would start with our actual velocity after 0. As in our experiment, would the time this object take to reach the ground be the same, longer, or shorter that it took during free fall? So the total time it would take to reach the ground would be longer because the object has to go both up and down back to the initial position, which is double the distance. When you're just dropping it in free fall, it's just going to fall one distance instead of two. So what does it mean? If the mass of the object was greater but the shape remained the same as in our experiment, will the time this object take to reach the ground be the same, longer, or shorter than the time it took during free fall, assuming there's no air resistance? So if the mass were greater, it would take the same amount of time to fall as the other object in free fall because time to fall depends on acceleration due to gravity, 9.8 meters per second, and not mass. However, if there were air resistance, it would probably fall faster than the original object because the heavier the mass, it makes air resistance have a smaller effect, therefore it would fall faster.